There was a devastating famine in Africa in the 1980s that killed up to 1 million people. Back then, it seemed the drought that helped cause this catastrophic event was simply due to climate variability. But now, more and more research suggests that it was caused, at least in part, by something the US and Europe did to cool the North Atlantic Ocean.
Your corporation misconcepts have been chosen to be made inoperable. You're poisoning us for profit. God sees you, we see you, and we're coming. Your infrastructure can be eliminated.
We're talking about solar geoengineering. It would look something like this. Thousands of planes would fly very high and use nozzles to inject millions of tons of light-reflecting particles into the stratosphere. It would create a thin chemical cloud of those particles around the whole planet, blocking some sunlight from reaching the surface. It would mimic a giant volcanic eruption, which we know cools the Earth. Back in 1991, Mount Pinatubo erupted in the Philippines. It was the largest eruption to affect a densely populated area, creating avalanches and giant mud flows that left more than 700 dead and 30,000 homeless. It also spewed a cloud of 20 million tons of sulfur dioxide particles into the stratosphere. That chemical cloud was hundreds of miles across and reflected about 2% of sunlight back to space. And in 1992, the Earth was cooler than in 1991. Modeling studies have found that it could reduce the intensity of heat waves, for instance. Apparently, it could reduce the rate of sea level rise. It could reduce the intensity of tropical storms, but it also comes with significant risks and uncertainties. Things like mass famine, mass flooding, drought of kinds that will affect very large populations. It could weaken monsoons in India, China, and Africa enough to affect crops. It could eradicate blue sky. A 2016 opinion poll conducted by the Harvard Group doing solar geoengineering research found that 67% of subjects support its use. One reason this technology is appealing, it's cheap. One study estimates it would cost an average of $2.25 billion globally every year for the first 15 years of deployment. Compare that to the $500 billion the US government estimates it will cost. Just the US by 2100 if no action is taken against climate change, or the $1.6 to $3.8 trillion projected global spending by 2050 on low-carbon energy production. You can also compare it to direct air carbon capturing, another climate change solution backed by Bill Gates and by big oil. It involves sucking billions of tons of carbon out of the air, and at $100 to $200 a ton, it could be big business. Bill Gates is among a dozen individual donors and 14 foundations backing the first stratospheric solar geoengineering experiment out of Harvard. It's called Stratospheric Controlled Perturbation Experiment, or SCOPEX. A high-altitude balloon will lift instruments about 20 kilometers into the stratosphere, where it will release less than 2 kilograms of different naturally occurring chemicals like calcium carbonate and sulfates, and then measure the change in atmospheric chemistry and light scattering. The Harvard group that runs SCOPEX and other experiments has raised more than $16 million, more than double any other solar geoengineering effort. And annual global funding has gone up from $1 million in 2008 to $8 million in 2018, with the majority of that funding coming from the US. The first phase of SCOPEX will cost around $3 million, with much more needed for wider research on solar geoengineering. To this point, stratosphere injections have only been tested with climate modeling. Sometimes, rogue experiments, planet-wide solar geoengineering, will require buy-in from the international community. You know, in our simulations, we found China got warmer and drier relative to the past when you stabilize global temperature, and India was now cooler, wetter. In 2015, the international community did come together when almost 200 countries signed the Paris Agreement on climate change, agreeing to limit global temperature rise to less than 2 degrees Celsius. On one hand, there are the potential downsides of geoengineering, from the risks of conflict, harm to human health, and unintended disruptions to the climate system, to the possibility of triggering humanitarian crises and even providing a get-out-of-jail-free card for the fossil fuel industry. Many scientists oppose solar geoengineering due to the significant risks and uncertainties associated with it. Solar geoengineering is a testament to human ingenuity, but also a stark reminder of our responsibility to this planet. It represents a potentially powerful tool, but one that comes with immense risks and ethical quandaries. Do we continue to research it as a last resort, or is it simply too dangerous to ever consider deploying? Thank you for watching. Don't forget to like, share, and subscribe.